Hello, Algebra students, and welcome to another video lesson. We are in section 9-4, day 1. We are going to solve quadratic equations by factoring today. So in the last lesson, we were talking about how to solve by using square roots. That only works if b equals 0. So square roots only works if b equals 0. But what if b doesn't equal 0? So in this situation, we can use factoring. So just to remind you what we're trying to figure out, we are trying to calculate roots, or where the parabola crosses the x-axis. So we are trying to calculate where the parabola crosses the x-axis. That's what we're trying to figure out. We can use that, or we can use factoring to figure that out. But first, we need to talk about an element of this, which is the zero product property. And you're going to see what I mean by that in just a moment. So, or how this relates. So for any real numbers, a and b, if ab equals 0, then either a is 0 or b is 0. In other words, here's what we've got going on. We've got a times b is equal to 0. What is the only way that we can get a number to multiply to 0? Either 0 times b equals 0, or a times 0 equals 0, or they're both 0 and 0 times 0 equals 0. There's no other way around this. Either a or b or both of them have to equal 0. So we can now apply that down here. We have solve using the zero product property. This whole expression, x plus 1, times x minus 3 is equal to 0. So this whole thing times this whole thing equals 0. One of these two things has to happen. Either this one equals 0 or this one equals 0. It's got to be one or the other. I guess it could be both. Well, how do we make those equal 0? How do I get this whole expression right here to equal 0? What I'm going to do, I'm going to set it equal to 0 and then solve for x. So here, this would be x plus 1 equals 0. Subtract 1 from either side. X equals negative 1. This is a possible value for this right here. Let's do the other one. I have x minus 3 is equal to 0 now. I'm going to add 3 to both sides, getting me x equals positive 3. So these are my two values that x could be. Because remember, I need something times something equals 0. But what does this whole expression, because it has parentheses around it, it's 1 unit. So what do I need this whole value to equal in order for it to multiply to 0? I need this whole value to equal 0. Let's do another one. Example B says 4x plus 1 in parentheses and then times x minus 5 in parentheses. One of those sets of parentheses, at least one of them must equal 0 for them to multiply to 0. So I'm going to set them both equal to that. 4x plus 1 is equal to 0, and x minus 5 is equal to 0. Let's solve for x. I add 5 on either sides, getting me x equals 5 here. This one's going to require 2 steps, so I'm subtracting 1, getting me 4x equals negative 1. Then I divide by 4. X equals negative 1/4. Let's do this guy up here. So remember, I have this whole quantity times this whole quantity is equal to 0. To have any two numbers multiply to 0, at least one of them must be 0. So I'm going to set the first value equal to 0, then the second value equal to 0. So this is 7x minus 2 is equal to 0. And this one's 5x minus 4 is equal to 0. I'm going to add 2 to both sides of this one, getting me 7x is equal to 2. Divide by 7. X is equal to 2/7 here. Just leave it in fraction form, no big deal. Let's solve for x over here. I'm going to add 4 to both sides. Now I have 5x is equal to 4. Now divide by 5. X is equal to 4/5. If I were to take 4/5 and stick it into this expression, I would get this whole thing is equal to 0, this whole set of parentheses. And anything that this could be times 0 is going to equal 0. Let's do one more. This one looks a little bit different. The two parts on this one, if you needed to put parentheses around that x to see it, we have something times something is equal to 0. Well, either this x right here needs to equal 0, or x minus 4 equals 0. So if we add 4 to both sides, if x were to equal positive 4, let's look at that real fast. If x were to equal positive 4, then this would become 4 times 4 minus 4 is equal to 0. Well, 4 minus 4 is 0, so 4 times 0 is equal to 0. Yeah, that checks out because 0 equals 0. So notice, when I substitute the value back in, will that get the expression to balance? That's what we're going to apply. But how do we get our equation to already be separated into two sets of parentheses like this? That's what we're going to look at next. We are going to solve quadratic equations by factoring. We have already factored in the last section. That is when we took a trinomial and we broke it down into two binomials. We're going to do the simpler version today and then a slightly tougher example or slightly tougher examples in a future lesson. So there's a couple things I want you to notice. It has to be in the form ax squared plus bx plus c equals 0. We want to make sure that it's in this form. So it must equal 0. And we have to make sure that we have an expression that can be factored. There are lots and lots of different types of examples that can't be factored. So we want to make sure that that is possible. And if we can't factor it, then I will teach you a different strategy later on. But for right now, we're not going to worry about that. Okay. So looking at just this first example, is this in the form ax squared plus bx plus c equals 0? Yes, it is in this form, so I don't need to switch anything about it. I'm going to try to calculate the roots. So where are the roots, basically, is what I'm asking myself. That's what I'm trying to calculate. In order to calculate that, I'm going to solve for x when it equals 0. I'm going to solve for x when the equation equals 0. Okay, so I'm going to just let this equal 0 keep coming down. The equals 0 is just hanging out. We're going to focus on this right side of the equation, and we are going to factor. Now, there's a pattern that we followed with factoring, but we did it a long time ago. So let's talk about that. We are looking for numbers that multiply to the last and add to the middle. So we're looking for numbers that multiply to 15, like 1 and 15, or 3 and 5, that add to 8. 3 and 5 is my magic pair. So I'm going to take that 8 and I'm going to split it into those two values. So 8x is turning into 3x plus 5x, and then I carry down my 15, and I carry down my x squared. After that step, I'm going to split this into two parts. So I've got the first half, and I've got the second half. Now I want to figure out the GCF of the two halves. So for the first half, I can pull an x out, and I have x plus 3 remaining. For the second half, I can pull a positive 5 out, and I have x plus 3 remaining again. Now I rewrite, so I have x plus 5 times x plus 3 is equal to 0. There is no value difference. So this guy and this guy, these are the same equation. They're just written differently. What we're doing here, we are using a different strategy to solve for the roots or the solutions or the zeros. So far, you've learned how to graph to find roots and you've learned how to use square roots. But now, what if there's not a perfect square? What if we don't want to graph? This is the next option. We can factor it. So we're going to factor, but remember this is set to 0. So what does x have to equal for this value to equal 0? So I'm going to take both of my 2 halves and I'm going to set them equal to 0 to figure out what that x must be. So x plus 5 equals 0, x plus 3 equals 0, x could equal -5 or x could equal -3. And there we have it. Let's do example B now. In example B, we are going to factor once again. Okay, we're looking for numbers that multiply to -14 but add to -5. So things that multiply to -14, -1 and 14, -2 and 7, or +2, -7. I'm going to use +2, -7 because that adds to the negative middle value. So that is going to be split up into 2 sets of parentheses. So I'll rewrite the middle term. I'm going to say plus 2x minus 7x. I got my x squared up front. So notice I carried down my equal sign and I carried down my 0. Now I'm going to split this into 2 halves. So I've got my first half and I got my second half. All right, what is the GCF of the first half? I can pull an x out, leaving x plus 2 remaining. For the second half, I can pull a -7 out, leaving an x plus 2 remaining again. And all of that's still equal to 0 based off of my equation. I want to rewrite the left side, getting me x plus 2 times x minus 7, and all of that's equal to 0. So all I've done so far is factored the left side of the equation. What I'm able to do now is say, what would x have to equal to make this equation true? Something times something is equal to 0. Well, one of these values has to be 0 at least, because otherwise it wouldn't multiply to 0. So I'm going to say x plus 2 equals 0, x minus 7 equals 0, add 7 to both sides, subtract 2 from both sides. X equals -2, and x equals 7. Let's do example C. Example C is a little bit different than what we've seen so far. This is not in the form ax squared plus bx plus c equals 0. Notice I have ax, bx equals, and then the c value. I do not want the c value on the right side. I want it to be on the other side. So I'm going to add 10 to both sides to make this look like x squared minus 7x plus 10 is equal to 0. Now this is in the correct form because remember I need it to be like this. This is the form we use each time. That's the form we keep using. That's standard form. So now it's time for us to factor this. We're going to look at the front 2 terms. Or sorry, we're not going to factor it. We need to, not yet at least, we need to find our number pair. My apologies. We need to find 2 things that multiply to +10 but add to a -7. So +10, but multiplying to a negative could be -1, -10, or -2, -5. We know we need to use -2, -5 because they add to the middle. So now let's rewrite. I have x squared minus 2x minus 5x plus 10 is equal to 0. Let's factor now. So I'm looking at the first 2 terms. What can I pull out of those first 2 terms? And then what can I pull out of the second 2 terms? That's how I'm doing this. All right, for the first 2, I can pull an x out, leaving me x minus 2. For the last two, I can pull out a -5, leaving x minus 2 again. All of it's still equal to 0. I keep pulling the equals 0 down. I'm going to rewrite the left side, leaving me x minus 5 times x minus 2 equals 0. And now, something times something equals 0. Either this expression or this expression must equal 0. So I'm going to say x minus 5 is equal to 0 and x minus 2 is equal to 0. Solve both of them for x. This one's getting me x is equal to positive 5. This one's getting me x is equal to positive 2. So those are my two values. We're going to do two more just to make sure we know what we're doing. So this one is x squared minus x equals 12. Notice it is not yet set equal to 0. I have to have it equal to 0. We must use that form in order to factor. So I'm going to make this set equal to 0. And remember, you're allowed to do anything you want to an equation as long as you do the same thing to both sides. So I'm going to subtract 12 from both sides. That leaves me x squared minus x minus 12 is equal to 0. Now, if you need to put your invisible ones in, then you can. And now I'm looking for multiples of negative 12 that add to negative 1. Well, if two things multiply to a negative, then one has to be positive and one has to be negative. So negative 1 positive 12, or negative 3 positive 4, or negative 2 positive 6. None of these have worked so far. What if it were positive 3 negative 4? That adds to negative 1 and it multiplies to negative 12. So I'm going to take these two numbers and rewrite the middle term. So I have 1x squared plus 3x minus 4x minus 12 is equal to 0. Still have that equals 0 on there. We're working with an equation this time compared to our previous section or our previous chapter. For the first two terms, I can pull an x out of them, leaving me with x plus 3. For the second two terms, I can pull a negative 4 out of them, leaving me an x plus 3 again. I'm going to rewrite the left side, giving me x minus 4 times x plus 3 equals 0. But this literally means something times something is equal to 0. So in order for anything to equal 0, one of the values has to be 0. So what does x have to equal for this expression to be 0? So let's set it equal to 0 to see what that would have to be. If I solve for x in both of these, I'm getting x is equal to 4 and x is equal to negative 3. Alrighty. I'm just going to do one more with you guys in this note video and then we'll call it a day. So we are doing example E now. So let's look at this form. X squared plus 49 is equal to 14x. This is not in our correct form yet because it's not equal to 0. So we need to get that 14x to the other side. I'm going to subtract 14x from both sides. And I'm going to go ahead and put this in the correct order. I want the x squared and then the x and then the regular number. So I'm going to say x squared minus 14x plus 49 is equal to 0. I went ahead and put my x term in the center position so that I didn't have to rewrite it yet again. Now I'm looking for multiples of positive 49 that add to negative 14. So that we know both numbers are going to be negative. We could have negative 1 and negative 49 or negative 7 and negative 7. I'm going to have to use negative 7 and negative 7. So now let's split this up into two terms. I have x squared minus 7x minus 7x plus 49 is equal to 0 still. We're factoring by grouping right now. And we factored a lot in the last chapter, so this will probably be familiar to you. What can I pull out of the first two terms? I can pull an x out of them. So I have x minus 7. And then what can I pull out of the last two terms? I can pull a negative 7 out, giving me x minus 7 again. Let's rewrite. I have x minus 7 times x minus 7 is equal to 0. Notice how both of these are equal to the same value. That's okay. That just means we're only going to have one x value. What would x have to equal to make either of these equal to 0? Well, x would need to equal 7. All right, I'm going to do the rest of these examples in class with you. So until then, please have a wonderful night and adios.